Okay, so welcome back, and here's the theorem that follows the example I gave about using functions, continuous functions that behave similarly to the sequence. So in this theorem it says, consider a sequence a sub n such that a sub n equals f of n for all n greater than 0. So this part here is just saying, hey, it equals f of n, so we find a function that behaves the same way, so we're saying a sub n equals f of n for all n greater than or equal to 1. If there exists a real number L such that the limit as x approaches infinity of the function f of x equals L, okay, so if this limit exists and it equals L, then by comparison the a sub n, the sequence a sub n must also converge, and the limit has to be the same. That's what this theorem is saying. So again, if we can take a sequence, right, and we see the nth term, right, we have that explicit formula. If we can find a function that behaves the same way, in other words, if we can replace n with x, right, we have a function in terms of x, and if we can find the limit of that function, right, because it will behave just like this, it'll have the same values for all positive integers, and if that function has a limit as x approaches infinity, then that means that the function converges to that number, and if that's true, then the sequence must also converge and converge to the same number. Okay, so that's the theorem. Now we're going to use that theorem to help find the answer of convergence or divergence for some examples. Have a great day.